Hello everyone. Today we're going to look at problems of complex numbers. So the first problem that we have is to simplify this expression here. Z is equals to open bracket minus 1.2 plus J all multiplied by minus 5 plus J 1.3. So the question say that we must simplify the following expression, and then we must also make sure that our answer is in polar form. So is the instruction of the question. It says that the answer must be in a polar form. Okay. So what you do when you are multiplying vectors is that you treat them as, for example, binomials. I don't know if you remember when you were multiplying numbers inside the bracket. What you have to do is that your first term will multiply with all the terms in the other bracket. And then the second term will also multiply with all the terms in the other bracket. So they call this a FOIL method. Okay. So now you apply this method when you are multiplying complex numbers. So what you will do, you will have what? You will now say negative 1.2 multiplied by negative 5, which is going to give us 6. And then you say what? Negative 1.2 multiplied by 1.3, which will give us negative J 1.56. Then after multiplying with the first term, you also multiply with the second term. So it's going to be what? It's going to be J multiplied by negative 5, which is going to be negative J5. And then you're going to say what? J multiplied by J 1.3, which is now going to be what? It's going to be J squared 1.3. Okay. So now after we have what? We have simplified our expression. We must now do what? We must now simplify this J to the power of 2. Remember, J to the power of 2 is equals to negative 1. Okay. So now we know now here we have negative 1, which is multiplied by 1.3. So if we simplify here, this answer of ours here, it will be the same thing as negative 1.3. So J squared 1.3 is the same as negative 1.3. So when we simplify here, we're going to have what? We're going to have 6 minus 1.3. So this 1.3 here, I'm just grouping the like terms here. And then we have what? Negative J 1.56 minus J 5. Okay. So now we have grouped our like terms. That means we have the real part and the imaginary parts. We can just add the real part with the real part and the imaginary part with the imaginary part. So it's going to be 6 minus 1.3, which gives the answer of 4.7. And then now this one here is because it's minus and minus, that means we're going to add them. So it's going to be what? It's going to be minus J 6.56. Okay, I hope we are all following. So after we have answered, we have simplified the problem. Remember, they said that our answer must be in a what? In a polar form. So what you must do, you must convert this answer of yours into a polar form. So how do you do that? Let me just erase what I've written there at the top because I don't have space, because we already have the simplified expression. Now we are just writing this simplified expression in a polar form. Okay. So now when we write the expression in the polar form, remember we must find what? We must find our resultant, and then our resultant will be what? Will be square root of the real part squared plus the imaginary number squared. So we're just gonna take what 4.7 squared, and then we're also gonna take 6.56 squared. Even if there is negative in both sides, you don't have to put the negatives, because when you square them, they will always give you a positive answer. So you can just put the real part coefficient, and then you also put the imaginary part coefficient. I don't know if I'm correct to say coefficient, but you can just put a positive number only. You don't have to put the negative sign. So it's going to be 4.7 squared plus 6.56 squared. Okay, and then now we'll get our resultant. So our resultant will be, just put in a calculator, 4.7 squared plus 6.56 squared. So the resultant will be 8.07. Okay, so after we find the resultant, remember polar form has a resultant with an angle. So we must use what? We must use a tangent of theta so that we can find the angle. So tangent of theta, remember tangent of theta is equals to opposite over adjacent. Okay, so every time the opposite side will always be what? Will always be the imaginary part, and the adjacent side will always be the real part. So remember, on the Cartesian plane of the complex numbers, we have the real part as x and the imaginary part as y. So every time the opposite part here on the tangent will always be the coefficient of the imaginary part, and then the adjacent will always be the real part. So when we substitute here, you don't have to think about anything. You can just substitute the opposite as the imaginary number. So, but you can see now the opposite, it has what? It has a negative 6.56. And then also a real part, it has what? 4.7. Okay, so after you have identified this thing here, your real part and imaginary part, what I will advise you to do is to check actually where your resultant, which quadrant is your resultant. So let's say, for example, on our real part, we have a positive number, which is 4.7. We can just say, okay, we have 4.7 here. You don't have to put it. And then you can say now you have what? You have negative 6.7. So the negative side of the imaginary part, it will be at the bottom. So negative 6.56, it will be here, and that means our resultant will be here. So our resultant is actually at what? At the fourth quadrant. So remember now, in the fourth quadrant we have what? We have 360 minus theta. Yeah? So if it was on the third quadrant, that means it was going to be 180 plus theta. If it's second quadrant, that means it's 180 minus theta. Remember, on this on our Cartesian plane, our 0 always starts here. This is our 0 degrees, and then it will be 90 degrees, and then this is 180 degrees, 270 degrees, and here we'll have 360 degrees. So between 0 and 90, this is where we have our theta. So our theta will actually refer to it as a reference angle, and then we will always check if ever where is our resultant, where does our resultant lie, which quadrant is our resultant in. So in this case, it's actually at the fourth quadrant. So we know now the reference angle that we get here, we're going to put it as theta, and then we'll say 360 minus the reference angle. Okay, let me just erase here. So now we are looking for what? For the reference angle. So now our reference angle, it will be what? It will be second function tangent. And then when you put in the calculator, you don't have to put this negative sign. It will be 6.56 all over 4.7. and we get our reference angle, which is our theta on the Cartesian plane, which is going to be second function of 6 tangent second function of 6.56 all over 4.7. So the answer, the reference angle, will be equals to 54.38. So now the value of our angle, which is theta, okay, in this case I will just name it theta. It doesn't matter how you name it, because I can see here I'm saying minus theta, but this is actually a reference angle. This theta here is a reference angle, but here this theta, I'm referring to the actual angle of the resultant. That means I'm talking about the angle from the starting point, the x-axis, up until where the resultant is. That will be the reference, the actual theta. Okay, but the reference angle is actually this theta here, which means is the acute angle between 90 and 0. That theta is here, and then here it will be 180 minus theta, and then here it will be 180 plus theta, and then the fourth quadrant it will be it will be that 360 minus theta. So now our theta, it will be what? It will be 360 minus 54.38. So that means theta, it will be equals to 360 minus 54.38 is equals to 305.62 degrees. Okay, so now our Z in a polar form, it will be what? It will be R. What is our R? Is 8.07 at an angle of 305.62. Okay, I will just divide the questions with a video by video. So the next question, it will be with the video that is following. Thank you.